This lesson is for FST, lesson 6.4 on permutations. Before I reveal what a permutation is, I want students to look at this very first question that we're going to look at today. This is a typical word problem that you might encounter related to permutations. How many orders of finish are possible in a 7-horse race? Keep in mind that this doesn't have to be related to horses. It could be cars racing like NASCAR, or it could be people running around a track. But anytime you have people finishing in a certain order, that's the type of question you want to be considering for permutation type questions. So if we're thinking about 7 horses racing, and they're going to finish in a certain order, we're going to lay out 7 blanks, one for each horse. 1, 2, 3, 4, 5, 6, 7. Now just for labeling purposes, I'm going to label first, second, third, all the way down to 7th place. And so if you imagine all 7 horses are racing, all of them are attempting to win first place. Once one of those horses crosses the finish line and wins first place, there are now only 6 horses still racing for second place. Once one of those 6 horses crosses the finish line and earns second place, now there's only 5 horses left racing, and so on. And so you'll find that the numbers just keep decreasing until all the blanks are full. So we're going to go ahead and multiply all those combinations together. All those different possibilities together. A faster way of doing that, instead of having to physically type in 7 times 6 times 5 and so on all the way down to 1, is you can use a factorial symbol. You'll find that a factorial symbol looks an awful lot like an exclamation point, and that is indeed what it is, but in math class we refer to it as a factorial. That button is available on your graphing calculator on the black calculator right next to the G button, and you'll see that the exclamation point is one of your choices. When you utilize that particular symbol on your calculator, it's programmed to take the number that you gave it and to multiply by the numbers that decrease all the way down to 1. So when you do that on this question, you end up with 5,040. So there's 5,040 different ways that the 7 horses could finish their race in places 1st through 7th place. Follow-up question that you might have for a question like the 7-horse race question would be, what is the probability of picking the top 3 horses? Typically when you go gambling at a racetrack, which students may or may not be aware of at their young age, where they are probably not allowed to gamble yet, something they should consider is that the top 3 horses for 2nd and 3rd place tend to be the only places that count for winning any money when you gamble. So if we're talking about just 1st, 2nd, and 3rd place, then we would only fill in 3 blanks worth of information. So all 7 are still available to win first place. Once one of the horses wins first place again, now there's only 6 horses racing, but we're only going to care up until 3rd place. So we no longer care for this question who wins 4th and beyond. So when you multiply those together, you only get 210 different combinations, or 210 different orders of finish for 1st, 2nd, and 3rd place only. If we're trying to find the probability of picking the top 3 horses, so the top 3 winners, there's only going to be 1 combination or 1 order of horses that is the indeed winner that would win money. So we would say 1 out of 210 would be the probability. So let's talk more about this whole idea of permutations, since that's the type of question we're doing today. So permutations are the type of problem when you are arranging the objects in a certain order. So the key here is that the order matters. So someone's going to be first. Once someone wins the first place spot, they cannot win any of the other places. They can't win second place as well. So once that person has won first place or taken the first place spot, now there's less people in the mix to earn the next place, just like what we did with the horse race question above. So when you're doing a permutation, you're taking a certain number of objects, which we're going to call the n value, and we're going to arrange them in R ways. So they use a capital P here for permutation. You'll know that it's not a probability question because you'll see these little subscripts surrounding it. If you had a capital P with parentheses, then you'd be doing probability of the event. So if you see probability or the capital P here with these little subscripts, then you know you're doing a permutation. The way that the book wants you to calculate permutation questions is with a fraction. You'll do the n value factorial on the top. You'll subtract the 2 values from each other, and you'll do the factorial of that on the bottom. Keep in mind that when you do that algebraically, you end up with the number that you're trying to find the permutation of times all of the numbers less than it as you decrease all the way down to 1. So if we were going to use the formula here to arrange 9 things in 6 ways, we would do 9 factorial on the top. 9 minus 6 is 3 factorial on the bottom. So let's simplify that. Most of the time here, students would not be allowed to use a graphing calculator to type that in. They'd only have a baby calc available. So it would be important for students to write out what they're seeing here on this question. So hopefully students remember what a factorial is. It means take the number and multiply it by decreasing integers all the way down to 1. And I forgot the 4 there. 4, 3, 2, and 1. So that's 9 factorial on the top. On the bottom we only have 3 factorial. So notice that the 3, the 2, and the 1 on the top and the bottom are going to cancel out and make 1s there. So really all we need to do is 9 times 8 times 7 times 6 times 5 times 4, and that'll be our answer. I want to show students a shortcut method because most students are not very agreeable to having to write all of this down when they see a question like this. So a little trick for you is that the n number is the number that you start with, and the r number is the number of blanks you need. So if you start with the r number and list out how many blanks you need, in this case we would need 6. Then we start on the left with the n number, in this case the 9, and we fill in the blanks until they're finished. So 8, 7, 6, 5, 4. And then we just multiply those together. So wouldn't that have been much easier than having to write out 9 factorial over 3 factorial? And so then you just go ahead and you type that in on your calculator. There is no funny symbol here. You have to physically type in all of the numbers individually, so there's no shortcut for that. But at least in terms of the writing, you don't have to write the 3 factorial on the bottom if you utilize the shortcut. So when you type all of that in, you end up getting 60,480. So let's try the next one. If we take 8 things and arrange them in 2 ways, let's utilize the shortcut this time. I would need 2 blanks, and I would just start with 8, and then I would decrease that number until all the blanks are filled. So in this case, I only have 56 different ways of arranging 8 things in 2 ways. If we had done it with the fraction, it would have been 8 factorial over 8 minus 2 factorial on the bottom would be 6 factorial. If we write all that out, I'm going to stop after the 5 here and just say dot dot dot. On the bottom I got 6 times 5 dot dot dot. And so right away students can see that the 6's and the 5's and everything after that will cancel, leaving us simply the 8 times the 7. So the shortcut really saves time here. A lot of times they'll have you do questions that are already in factorial form. So let's say for example that they have you do 52 factorial over 49 factorial. So that's still a permutation question even though it's not set up like we're used to. So hopefully students know how to deal with the fraction if they're only allowed a baby calculator here. You would simply just start to write out what you know about the factorial symbol. Luckily here you don't have to write it all. Once you get to 49 you can quit because once you get to 49 the numbers are going to begin to cancel each other out. So all you'd have to calculate here is 52 times 51 times 50. And we end up with 132,600 different combinations. So students would be able to handle that no problem with a baby calculator, assuming that they remember what the factorial symbol allows them to do. Let's go back up to the 7-horse race questions here just for a moment, and let's write these in permutation form. This first question we were taking 7 things and arranging them in 7 ways. So we needed 7 blanks total, and we started with 7 and we decreased until all the blanks were filled. On our follow-up question we had 7 horses that were racing, but we only arranged them into 3 ways. So we only did 7 permuted with 3 there on the second one. Final thing we're going to do today is look at just one more word problem that students might come across that is a permutation word problem. How many different 4-letter combinations can be formed using the letters in the word equations? When you see a question like this, keep in mind that these are the only letters available. Once you use one of those letters, it is no longer available when you make that word, so repeats are not allowed. So if you count how many letters are available, there's 9 there, and we're trying to make 4-letter combinations. So we're doing a 9 permuted in 4 ways here. So that means we need 4 blanks, starting with the number 9 and decreasing until our blanks are filled. So when we multiply there, we're going to get 3,024 different four-letter combinations. Keep in mind here, students, that you're not necessarily making four-letter words. You're simply combining the letters into groups of four. So when you're making a word here, you might not end up making a four-letter word that makes any sense, but that would be one combination of four letters from this word. One final comment here for students is that if you encounter a situation where you have to do a 0 factorial, that always has to be a 1. If it ended up being a 0, then sometimes on the fraction you'd end up with a 0 on the bottom, and we know that that's not possible. So if you come across 0 factorial, that has to be a 1. One final note about the homework, as students are attempting to do number 12, keep in mind that you must read example 3 in order to get that question figured out. Otherwise, you need to simply do trial and error.